Hi, today we're going to study number theory. Okay, this has been a while. We in mathematics, cover algebra, right? Geometry, number theory, probability. There's some mixed problems, such like word problems, story problems. Right. So now we have to focus on problems on numbers. Okay. I begin with prime numbers. I know you should able to, first of all, you should know the definition of prime number, right? A number is not it cannot be written as product of two numbers which are not equal to 1. Okay, that's the definition of prime numbers. And you should be able to quickly write down the first 10 prime numbers. Okay, those are the prime, because when you do the factorization, sometimes you end up with 23 times something, but you should know 23 is a prime number. Okay, so those are the prime numbers. Okay, and my first question is going to be, let's begin with the problem first. Okay, so what is at least the whole number? Whole number is an integer, positive integer. Okay, so what is it? And divisible by 4 different prime numbers. Okay. And divisible by 4 different prime numbers. Okay. Now that's, if you should know the prime numbers, right? And they're going to be product of 4 prime numbers. You have to make the prime number as small as possible. So the prime numbers begin with 2, right? 3, 5, 7, 11, 13, 17, right? And so on. You just needed to look at the first 4, right? So product of the first 4 prime numbers. Yeah, first, right? So going to be 210. Okay. So the smallest of such number is 2 times 3 times 5 times 7, and I think it's 210, because 2 times 3 is going to be 6, 6 times 5 30, 30 times 7 20, 210. Okay, and so the next question is also about prime numbers. How many primes, okay, less than 50 have a 3 as a digit, right? So you should try to write down the prime numbers, which less than 50, okay? Then you look those who was a 3 as a digit, okay? Toby says 6. Right. So, well, yeah, you quickly go. You don't need to write down all the prime numbers, right? But you quickly begin with 3. The next one, between 3 and 10, there's only 1 here. Then between 10 to 20, it's a 13. Then between 20 and 30, that's only 23. 23 and right. Then from between 30 and 40, now them 2, 31, 37. Okay. Then between 40 and 50, that's a 43 is a prime number. Okay. So this is how do you list all of them. Okay. And the next problem is a little bit difficult. Okay. We only have one equation. Okay, the sum of 2 primes is 49. Okay, what is What is the sum of their reciprocal? Okay. So you have two prime numbers, okay? And the sum is going to be 49. And you want to find out the sum of their reciprocal, right? Of course, if you don't know P and Q, you cannot find the reciprocal, the sum of their reciprocals, okay? Because you only, if you combine them, you only get, and the P plus Q, the numerator is 49, right? Yes, but what is a denominator, right? Right? So this is another, but remember, prime numbers, most of them, except the first one, are all other numbers. So the sum of prime numbers usually is an even number. Remember, right? So in order to make it other number, the sum is odd, then one of them must be even. So you only determine one of them, right? P must be 2. Then Q is 47, and that's it. Okay? So that is, yeah. So because only when 2 added to another prime number, you get an odd number. Okay, so this is a key point. Okay, if you know this, then you can solve the problem, right? And then combine them, you get the 47 times 2, and 47 plus 2, so 49, and they multiply by 47 multiplied by 2 is 94. Okay, 49, 94. It's an interesting number. Okay. Right, so this is prime factorization. The next problem we'll do problem. So what is the greatest prime factor of the following number? 11 to the 126, 11 to the 127, 11 to the 128. Okay. So this is, you are, if you just 11 to the 126, then it has only one prime factor, 11. Okay. So what we're trying to do is just trying to find the prime factorization of this number. This number is the sum of 3 terms. Okay. What you should do? Well, the first step is to get a common denominator, a common factor, right? So the common factor is 11 to the 126. So this is going to be 11 to the 126. This first number is 1. The second one is 11. The third one is 11 squared. So 1 plus 11 plus 11 squared, that's a small number, right? Then add them together, 121, right? Plus 11, 132, then plus 1, 133. Okay. The question is 133 a prime number? 133. Okay. Maybe, maybe not, because this is a large number. It's beyond the 100, greater than 100. We cannot memorize all the numbers, prime numbers. We can only list like some prime numbers smaller than 50. So you should try to factor it, okay? And when you look at last digit is 3. The last digit is 3, then you, okay, maybe 7 times 9, all right? Something like that, 63. That's not a 63, so 133. So you try and just try, that's possible. Try and divide by 7, right? And then put a 7 here, 63, and here, then, right? Oh, great, you're lucky, right? So then you know that 19 is a prime number, 7 is a prime number. So this is already prime factorization. So 19 is the greatest prime factor of that number. In other words, we're just trying to factor this number, and so trying to find the prime factorization. So 19, you should know that this is a prime number. Then right? So don't stop there. 133 may be not a prime number. Maybe it is. Like 33 is not a prime number, right? But this, yeah, 31 is a prime number. Okay, 31 is a prime number. So Then you think about which two numbers. The last digit, right, should be 3. So last digit should be 3. So 7 times 9 gives you 3. What else? I don't think, 1 times 3, right? Is also 3. Okay, that's only two options. Okay, 7 times 3. 7 times 9 gives you 3. Last digit is 3. Okay. Yeah, let's look at the next one. Okay. When we look at, when you look at a number like this, okay, it's a reciprocal and integer. Okay, reciprocal integer, and here's the integer. My question is, if we express this as a decimal, in decimal form, it could be 0.000, right? Could be repeated, could be, so the question is, when this one's the reciprocal of this integer is a terminating decimal. Okay, do you remember that? Okay, so we want to find out this is a terminating decimal if and only if n is in certain form. Okay, question is what n could be. Okay, what n could be. So like 1/2, it's going to be 0.5. That's great, right? And 1/5 is 0.2, right? Right? But the 1/3 is going to be 0.3333. So it's not terminated decimal. So you try a few examples. You make a conjecture then. Okay? You make a conjecture. Okay? So we find out 1/n, the reciprocal and the integer becomes a terminating decimal if and only if n must be the prime factorization only contains 2 factors, 2 and 5. Okay, and if there's another prime number there in the product, then you're not going to get a terminating decimal. Okay, like 1/3. Okay, and 1/6. No, because 1/6 is 1/2 times 3. So there is a 3 there. If you use a calculator and you're not able to get terminated decimal. Okay, so you can check that. 1/6. Let's look at 1/6. Yeah, I'm going to look at the 1/6. Yeah, so 1 divided by 6, it's going to be 0.1666. It's not a terminating decimal. Okay, so only when n has a prime factorization 2 to the power p and times 5 to some power q, then 1/n is going to be a decimal, terminating decimal. Okay, we just discovered that. Okay, and we check that using examples. And let's look at example. How about like 2 square times 5 cube, right? And I'm pretty sure this is going to be terminating decimal. Okay, so 1 divided by 4, and then divided by again 125. Okay, so it's going to be 0.002. Okay, it's a terminating decimal. Okay, cool. Okay. So here's a question. How many positive integer less than 40 have their reciprocal terminating decimal? Okay, we have to count those numbers. So the n must be in the form 2 to the p and 5 to the q. Okay, p, q are integers. Right. So how do you do that? Well, first of all, you do the you look. Yeah, my suggestion to you is you let p to be 0, 1, 2. Then for each choice of p, then you get, yeah, when p equals 0, right? Then you look at the q. Q could be 0, and you know this is called yeah. It's better to draw a matrix. Okay, so this is q equals 0. Then you 2 to the 0, 5 to the 0, right? That's a 1. Then q equals 1, 2 to the 0, 5 to the 1. Then q equals 2, right? 2 to the 0, 5 square. And then q cannot be 3, because otherwise you get a number larger than 40. Right? Then you look at the next one, p equals 1. Okay? And you will get right? And you cannot put 2 to the 1 times 2 squared, then you get 50. So you stop there, right? Then p equals 2, 2. Okay, so this will be 4 times 5, 20. Let me check. Yeah, 4 times 5, yeah, 20. Then 4 times 5 square. Now it's larger than 40. So then p equals 3. Okay, and 8. And I think this will be 40, because 8 times 5 is 40. So you stop there. So then you count how many of them, right? So 1, 2, 3, 4, 5, 6, 7. So there are 7 such numbers there. Okay, so you get all of them. Right? So how many you got? 8, 9. Oops. Okay. So the way you do it, it's hard to list all of them if you don't do this in this order. You choose a variable p from 0 to 1 to 2, 3, 3. Then for each fixed p, you list all the possible numbers horizontally, okay, on the horizontal line, and then you just count. Okay. All right. Yeah, we play with numbers. Okay. Now, the next one is here. The integer n is the sum of 3 consecutive positive integers, and is divisible by 7. So we have to figure it out what is the least positive value of n. Right. So we are looking for the smallest. Okay. We don't know which one is divisible by 7. Okay. But n should be the sum of. There's a couple ways to do this problem. Okay. So the sum of 3 consecutive positive integers. Okay. The sum of 3. So the best way to do. Okay. There's a couple ways to solve them. So 3 consecutive integers, right? So you can write the integer in the following form. And I cannot use n, let's just use p, okay? P plus 1, p minus 1. So if it's 3 consecutive integers, you express in this form. So the sum is going to be p minus 1 plus p plus 1, which is 3p, right? Okay. And so the sum must be in this form, must be a multiple of 3. But there's additional condition, divisible by 7. So clearly P is divisible by 7, but smallest value for P is 7. So therefore the answer is N equals 3 times 7, which is 21. Okay. This is a more general way to solve the problem. Now you can also by guess and try. Okay, you can by guess and try, and you can begin with, 1 plus 2 plus 3 equals 6. It's not true. And 2 plus 3 plus 4 equals 9. Okay, it's not divisible by 7. Then 3 plus 4 plus 5, and it's going to be 12. It's not. Right? 4 plus 5 plus 6, and that is still not. It's 15. Okay. Then try 5 plus 6 plus 7, and that is still 18. Too bad. Okay, we're not lucky, right? And then the next one is, yes, 6 plus 7 plus 8 is going to be 21. Yes, but takes so much more time. But you can still solve it, right? That's by guess and try. All right, so now we are going to gradually get into the divisibility of functions. Okay, so let me ask you to do the following problem. So I'm not going to do always. Okay, what is the largest 3-digit number which is a multiple of 32? Right. Yeah, something like 992. Okay. Now, what is the best way to do? Right, you cannot begin. It's multiple of 32. So the number, you always use this condition first, multiple 32. Okay, if it's multiple. Okay, so 32 times P. Okay, this is a 3-digit number, right? The largest 3-digit number without any assumption restriction is going to be 999, right? So 32 times P should be less than or equal to 999. We are looking for the largest possible value for P. Okay, so then P is less than or equal to, and then this time you have to use calculator if you have a calculator, and 31.22. Okay, so P is the integer. P is less than or equal to 31.22. So P is the largest possible value you can choose is 31. Okay, then this number N is given 32 times 31 is 992. Okay, that is the answer. Okay. Yeah, first of all, you have to guarantee, if you begin with 992, then divide by 32, yeah, it's not integer. Then 998 divided by 32, it's not integer. Then if you try like that, how many numbers you have to try, right? It's 8 numbers. It takes forever. So here you just only do one division. So you express the number, okay, as 32 times P, then you just determine its largest possible value for P. Yeah. So here's the next problem. What is the greatest 3-digit multiple of 23 Okay, now this is slightly different. Okay, that can be written using 3 different digits. Okay, so you're looking for 3-digit multiple of 23. So the number must be a multiple of 23. But that can be written using 3 different digits. Okay, clearly 992 is not a, okay, for example, it's not, it has 2 identical digits here, right? 9. So I told you that you have to use a multiple condition, multiple of 23. So the number p, times 23. This is our number. Okay, it is 3 digits. So it's always less than or equal to 999. You're looking for the largest possible value for p, right? So did this computation, p is you divide by 23 on both sides. It's about 4343. Okay, so clearly the largest possible value, of course, without using without additional assumption, your answer will be 43 times 23. Okay, so your answer will be, the possible value for p is going to be 43, 42, 41, and so on, right? Yeah, this is, so we have to check, right? 23 times 43 is 989. It does not have 2 different digits. Okay, 42 is 966. It's not, and 23 times 41 is 943. So yes, this is the number I'm looking for. Okay, this is the number I'm looking for. Okay. So this is probably slightly different from the above one. There's an additional condition there. So let's try next one. Yes, this time we are going to count how many integers between 10 and 2019 are multiple of 7.
Wow.
There's a lot. So it's multiple of 27. You have to use that condition first, right? Yes. You have to use that condition first. Oh, they already gave me 287. No, Alex, this is a problem.
Hey, Sam.
288?
287. 287.
When we say between 10 and 2019, yeah, 2019 is not included. Okay, so the number must be written in the form 7p. It's less than 2019, greater than 10. Okay, so you divide both sides by 7. Okay, then depends on how many choices for p, right? So this side is about 1.4, estimate. The other side, 2019 divided by 7. Okay, so it's gonna be 288.4. Okay, so clearly p is integer, right? P is greater than, so p must start from 2, 3, all the way to 188. So if you have this many choices for p, then how many total choices there, right? Okay. 287. Yeah, from 2 to 288, there are 287 numbers, right?
Yes.
Yeah. 287. 287 choices for P.
Yeah.
Right, so a number is divided by 7. Sometimes we have to, we have to figure out whether a number is divided by 7, divided by 9, divided by 11. Okay. So we're going to find a formula if possible. Now, a number divided by 5, what you can check? A number, whether a number is divisible by 5. Right? Either the last digit is going to be 0 or 5, right? Okay. So a number, so a number is divisible by 5 if and only if the unit digit is going to be 0 or 5, right? Okay. How about divided by 4? Divided by 2 is easy, right? It must be even number, right? Divided by 4, how do you check? A number is divisible by 4. Okay, how do you check? So that number should be, well,
20.
no. How do you check? If I give a 4-digit number, how do you check? You basically just need to check the last two digits. Okay. If this number, we assume that this number n. Okay. So n, we assume n has more than 2 digits. Okay. We assume that. Then, if and only if the number formed by last 2 digits is divisible by 4. Then it's really easy to check, okay? Yeah. Then the 2-digit number formed by the 10th and units digit is divisible by 4. Okay. The reason is, look at this. Okay, I'll give you an example. Okay, like 700. Okay, 7,124. Okay. Now, whether this number divides by 4. Okay. The reason is this is a 7,100 plus 24. So this is always divisible by 4. Okay, because 100 is always divisible by 4. All you have to do is look at last two digits. In this case, of course, it's divisible by 4 because 20 plus 4. Okay, 20 is divisible by 4. But sometimes you have to look at 2 digits. Okay, so this is always divisible by 4. Right, because 100 is divisible by 4. Okay, so 20, then you just need to look at 20, whether 24 is divisible by 4 or not, right? 28. Okay, so it's easy to check then quickly. Okay. It's very difficult to check whether a number is divisible by 7. Yeah, let's begin with 2. 2 is okay. The number is even, then divide by 2. 4, 3. 3, yeah, we were talking about 3. 4, 5, 6. How do you check whether a number is divided by 6? Okay. How do you check whether a number divided by 6? Yeah. By 3 and 2. Okay. By 2 is easy, just even number. So you divide by 2 first. Then what do you get? Okay. Then you look at whether divided by 3. Okay. Now the difficult part is divided by a number divided by 7. 7, 8 is okay, 9 is okay. So we are going to focus on I don't have a general rule here whether a number is divided by 7, but we do have a number whether divided by 3 or 9. Okay, so let's take a look at the 3-digit. Okay, let me state the theorem first. Okay, a number is divisible by 3 or respectively by 9 if and only if the sum of the digits, which is small number, is divisible by 3 or by 9. Okay, so we 9 and 3 we take care of. And why is this true? Okay, why is this true? Well, you just look at a 3-digit number. Okay, three-digit number. Okay, so 3-digit number we use we denote by this A and B and C. Okay, A, B, C are all digits. And this is going to be, A is going to be 100 times A, right? And B is 10B and the C. Okay, but 100 can be decomposed to 99, sum as 99 plus 1. So this is going to be 99A plus A. This is going to be 9A plus A. Okay, B. So you group this together, it's a sum of integers, A plus B plus C. And clearly this is a divisible, always divisible by 9, right? Of course, divisible by 3. Okay, never worry about. So a 3-digit number is divisible by 9 if and only if A plus B plus C is divisible by 9. Okay, a 3-digit number is divisible by 3 if and only if A plus B plus C is divisible by 3. That's the proof. Okay, in general, for at least for 3-digit number. For integers with more than 3 digits, it's the same idea to prove. Okay. So now we take care of all the, we check whether a number is divisible by, let's see. Okay. Let's look at this number. Let's look at the number. Okay, 3, 4, 5. 1, 2, 3, 4. Okay. Let's look at this number. Okay, I'm not sure it's divisible by 3 or not. Okay. This is an even number, right? Yeah. So let's check. Like add them together, all the digits, right? 2 plus 4 plus 5 plus 1 plus 2 plus 3 plus 4. Okay, it's easy to figure out. Here's a 6, 6, 12, right? And then here, and you get 5, right? So 5 plus 4, 9. 9 plus 12 is going to be 21. Okay, so this is a divisible by 3, but not by 9, right? They're not by 9. So we can see that 2004. No, it's much larger number. Okay, yeah. So this very large number is divisible by 3, but not by 9. All right, it's not by 9. Got it? Yeah. But then you can also tell that this number is divisible by 6. You know why? Why is this number divisible by 6? This number divided by 6 just because it's also even number, right? So divided by 2 and by 3, then, but it's not divided by 9, okay? Because the sum of the digits is only 21. Okay, so let's do the next problem. A 4-digit number in the form 2x47, okay? This is a divisible by 9. What is x? Okay. We're trying to determine the value of x. Maybe there are more than one solutions. There must be digits so that this number is divisible by 9. Now, how to do that? Just add all the numbers together, right? So 2 plus x plus 4 plus 7. After you simplify, it is going to be x plus 13. Okay, x plus 13. Now this is divisible by 9, but what is the largest possible value you can get? Right? Right? This is already greater than or equal to 13. Okay, so x plus 13 is already greater than or equal to, when x is 0, that's a 13. Less than or equal to 9 plus 13, that will be 22. So there is only one number divisible by, between those two numbers divided by 9. X plus 13 should be equal to 18. So x is going to be 5. Okay, that's only one solution. Okay, so I'm going to ask you to do the following problem. What 3-digit number, okay, was unit digit 7 and 100 digit 5 is divisible by 9. Okay, there are a couple conditions, right? You have a 3 digits. This is a wait a minute. This is a 3-digit. Yeah. So the number is already fixed. Unit digit 7, 100 digits 5. So the number is going to be 5x7, right? Yes. All right, please do this. Yeah, 567. So the way we do is x plus 5 plus x plus 7, which is going to be 12 plus x, right? And divisible by 9. So 12 plus x should be equal to 18. X should be equal to 6. No, this is the only choice. Okay. I think the most difficult problem is to check whether a number is divisible by 7. To check whether divisible by 7, it's not easy, okay? This is the only digit less than 10, less than 9, yeah, have a trouble, yeah. But beyond the 9, right, you get 10, right? You can easily check whether the number is divisible by 10. So how about 11? Okay, 11, we do have the so-called alternating sum. Let me write down the theorem first. Okay, a number is divisible by 11 if and only if the alternating sum of the digits is divisible by 11. Now, what is the alternating sum? Not the negative sum. It just changes signs. Okay. For example, you have like 2, 3, 4, 1, 2, 1, 1, right? Let's look at this first. Okay. I want to see if it's divided by 7 using this trap. So alternating sum means 2 minus 3 plus 4 minus 11 plus 1. Okay. Right. Alternating sum, change the sign. So you will see that -1 plus 4 is 5. So this is 5. 5 is not divisible by 11. Okay. This is not divisible by 11. So that means the whole number is the original number is not divisible by 11. Okay. So this is the implies 2, 3, 4, 1, 1 is not divisible by 11. All right. But let me give you a proof why this is true. Okay. Just look at 3-digit number. Okay. Look at a 3-digit number ABC. Okay. I want to see whether the alternate sum would be A minus B plus C. Okay. Okay. Alternate sum is ABC, which is 100A plus 10B plus C. Okay. Now, how can I get 11? 99 is divisible by 11. Great. So I put the A here. Okay. But the 10B should be 11 minus 1. Right? Then you plus C. Okay. So you get alternating sum here. Okay. So this part is always divisible by 11. Look, right? Divisible by 11. Maybe you can find a good way to check whether integer is divisible by 7. Okay. If you figure it out, maybe not like as simple as this one, but if you're able to figure it out, just let me know. Okay. You can write down on a piece of paper. Okay. And show to me. Okay. Then a 3-digit number is divisible by 11 if only if A minus B plus C is divisible by 11. Right. So -1, negative, yeah, it's a 3, sorry, 3, yeah. Okay. Yeah, 4 minus 1 is 3, so I saw it. All right. So we can check. So here's a question. Okay, still the same problem. If a 4-digit number, 2x 47 is divisible by 11, what is x? Maybe you have more than one solution. Okay. So how to do that? How to do that, right? So the alternate sum is 2 minus x plus 4 minus 7. Be careful, yeah, do the computation. Okay, so that'll be 2 plus 4 is 6. 6 minus 7 is -1. So it's -x minus 1. Okay. So this is a divisible by 11. Okay. What is the possible value for this? Do we have a solution? Okay. And look at this, right? The largest possible value for this number is -1. Okay, because when x equals 0. But x could be -9, right? Yeah, here's x here, could be negative, so -10. between -10, this is the smallest possible value you can get when x equals 9. Between -10 and -1, there's no integer divisible by 11. Okay, so no integer, okay, is divisible by 11. Okay, x cannot be 9. Okay, so no solution. Yeah, it's no solution. You cannot. Okay. So no integer between -10 and -1. Okay, I should say that. And divisible by 11. So that's why no solution. You're not able to find the solution. All right. All right, so now we are talking about prime factorization, and I want to count how many factors does a number have. Okay. So first, yeah. So let's begin with the problem. How many factors does 72 have? Okay. So what does that mean? First, we should understand what is called a factor. A number is called a factor of 72. If 72 is divisible by that number, right? So first thing you have to do is prime factorization. 72 is going to be, you know, it's even number, right? I think 8 times 9. But 8 is given 2 cubed, 9 is a 3 square. So a fact of 72 must be in the form 2 to the some power p and 3 to the some power q. Okay, a fact of 72 must be in the form 2 to the power q and 3 to the power q. Okay, now p and q are not arbitrary. P cannot be larger than 3, so from 0 to 3, right? Q cannot be larger than 2. So, but that can be any of the integers between 0 and 3 for P. For Q, any integer between 0 and 2. So how many choices for P? 4. How many choices for Q? 3. 4 times 3? 12. Okay, so they are 4 times 3, which is 12 factors. Okay, you can list all of them. Yeah, you can list as a we call it matrix. You know, have you heard of a matrix, right? So that you can list it like when P equals 0 and 3. Okay, that's the first row, right? And this side, that's Q, right? Q from 0, 1, and 2. And this side, P from 0, 1, 2, 3, 4. So you list 3. Okay, so you list 4 rows, 3 columns. Yeah, this is where how do we list them? So they are all the factors of 72. But how many of them? Right, just like find the area, you know, the 4 rows, 3 columns, 4 times, okay, 4 times 3 total 6, right? So there's 6 factors. They're all here. This is called matrix in mathematics. Okay, yeah. So this matrix has 4 rows, 3 columns. Okay. My question is, can you find the sum of all the numbers? Yeah. What is the sum of all factors. How do you add them together? 12 there, right? What is the best way to add them together? Well, because those numbers line up in a very nice order. So what they do is you can add all the numbers in each row first. Okay, so the first, and then you see that there's common fact, right? Let's use a red pen. 2 to the power 0, right? And then you have a 3 to the power 0, 3 to the 1, 3 square, if you take it out. And then for the second row, all the three numbers, add them together, maybe 2 to the 1, and the only difference is, from 2 to 0 to increase it to 2 to the 1. And the third one is 2 square, because every time there's a 2 square there. You take it out. Then you add it all together from here, right? This is from there, right? Right? And then you will see this is a compact now becomes. Right? So what you get is that 2 to the 1 plus 2 to the 1, 2 to 0, 2 to the 1, 2 squared, 2 cubed, and then this is a common fact. I did not multiply them together. I just still keep it. This is a common fact. Okay? And then you add them together vertically. So what you get? You get a product of two numbers. Okay? So the answer will be, this is true actually in general. So the answer will be the sum, I already explained to you, is going to 2 to the 0. So the question is, how do you add them together? Now you can do that directly right now, no problem. 1 plus 2 plus 4 plus 8. Here's 1 plus 3 plus 9. Let me add them together. Here's a 15, and this is a 13. So 15 times 13 is a sum. Okay. If I have too many terms, how to add them together, right? This comes to the problem is 1 plus r squared, r cubed, r to the nth power. Okay. It's a geometric series. It's called. Okay. It's called geometric series, and then this is going to be r to the n plus 1 minus 1 divided by r minus 1. So you can simplify for this. Okay. Yeah. For example, 1 plus 2 plus 2 squared, 2 cubed, 2 to the 2019, right? Okay, and it's pretty large, 2019. And this, according to the above, is 2 to the 2020 minus 1, but the denominator is very simple, just 2 minus 1. So actually, it's going to be 2 to the 2020 minus 1. So many numbers, add them together, just equal to 2 to the 2020. You'll be surprised, right? Yeah. Sometimes it's hard to believe. Okay. You have how many terms here? You have a 2020 numbers added together, and many of them very high power, right? 2019, but add them together just equal to slightly even smaller than 2 to the 2020. Okay, so this is called a double rule. It's increased very fast. Okay, so there was a story. There was a guy who the king awarded him for his contribution to the country. Then he replied to the king, said, every day when I come to see you, please give me, beginning with maybe 1 peanut, right? Next day give me 2 peanuts. every time I double it. Okay, every day, you know, you just double what you gave to me from last day, previous day. The king thought it's trivial. 1 peanut, first day, second day, 2 peanuts. Third day, 4 peanuts, 4 peanuts, okay. Okay, okay, that's right. Right, 1 year later, you know, he cannot afford it to that. Okay, so 2000, yeah, you can look at how big of the number. So this is the double. Double. Every time it double, it grows very, very fast. Okay, don't jump into the trick here. Even you know your cell, for example, the cell is right, split double. You know, repeat it, right? This is yeah. So you don't it's harder to imagine how fast it's grew. Okay, so we stop here, and you'll get a homework assignment right away.